Do you know that there are easy to understand steps that you can follow to convert a rectangular equation to a polar equation and a polar equation to a rectangular equation? I'll explain exactly what these steps are and walk through 6 example problems. Welcome to Understand the Math. We've created free guided notes that you can use as you watch this video and placed a link to them in the video description below. There's space in the notes where you can fill out the answers to the examples that we're going to do because you can't just watch someone do math, you need to do it too. To convert an equation from polar to rectangular coordinates or rectangular to polar coordinates, we need to understand how x and y are related to r and theta. X and y are used to represent a point in rectangular coordinates, and r and theta are used to represent a point in polar coordinates. You can see from the diagram here that x is equal to r cosine theta, y is equal to r sine theta. From the Pythagorean theorem, r squared is equal to x squared plus y squared, and lastly, tangent theta is equal to y over x. We'll be using these equations in the examples that we're going to be doing. Before we convert a rectangular equation to a polar equation or a polar equation to a rectangular equation, we need to know what the equation that we're converting to looks like. A rectangular equation can be written as x is equal to a number, y is equal to a number, y is equal to a function of x, or a function of x and y is equal to a number. I've written down an example of each so you can see what it might look like. A polar equation can be written as r is equal to a number, theta is equal to a number, r is equal to a function of theta, or a function of r and theta is equal to a number. Let's now learn how to convert a rectangular equation to a polar equation and walk through 3 example problems. There are 2 steps that we'll need to follow. The first step is to substitute in x is equal to r cosine theta and or y is equal to r sine theta. The next step is to simplify the equation into one of these 4 forms. To do this, we may need to use trigonometric identities to simplify the equation. The first equation that we'll look at is x squared plus y squared is equal to 9. This is the equation for a circle of radius 3 centered at the origin. Our first step is to substitute in x is equal to r cosine theta and y is equal to r sine theta. This gives us r cosine theta quantity squared plus r sine theta quantity squared is equal to 9. This is r squared cosine squared theta plus r squared sine squared theta is equal to 9. We see that there's an r squared common to both of the terms, so we can pull that out. And we write it as r squared times cosine squared theta plus sine squared theta is equal to 9. We know from the Pythagorean identity that cosine squared theta plus sine squared theta is equal to 1. So this gives us r squared is equal to 9. There are 2 solutions to this equation, and they're r is equal to 3 or r is equal to minus 3. R is equal to 3 is used more often because it's nicer to work with a positive number. Our second example is the equation y is equal to 2x plus 1. This is the equation for a line that does not pass through the origin. We'll begin by substituting in x is equal to r cosine theta and y is equal to r sine theta. This gives r sine theta on the left-hand side, and on the right-hand side we have 2 times r cosine theta plus 1. Since we have an r on both sides of the equation, it looks like we can write this equation in the form r is equal to f of theta. To do this, let's pull the r cosine theta from the right-hand side onto the left-hand side. We have r sine theta minus 2r cosine theta is equal to 1. We can then pull out an r, and then we have sine theta minus 2 cosine theta is equal to 1. We want to get the r by itself, so we're going to write this as r is equal to 1 divided by sine theta minus 2 cosine theta. You can see that the polar equation is a lot more complicated than the rectangular equation, which isn't surprising since our equation is a line and that's more easily described in terms of rectangular coordinates. If we go back to our first example, you can see that the polar equation is simpler than the rectangular equation, which makes sense because our equation is a circle, and that's more easily described in terms of polar coordinates. Let's now look at our third example. Our equation is y is equal to 1 over x, and this is called the reciprocal function. We let x is equal to r cosine theta, and y is equal to r sine theta. Let's plug these in. On the left-hand side, we have r sine theta, and on the right-hand side, we have 1 divided by r cosine theta. Let's simplify this by multiplying both sides by r cosine theta. This gives r squared sine theta cosine theta is equal to 1. We can then use an identity to simplify this further. We know that sine 2 theta is equal to 2 sine theta cosine theta. So we can plug in sine theta cosine theta is equal to sine 2 theta divided by 2, and that's equal to 1. We can then clean this up by multiplying both sides by 2, and we get r squared sine 2 theta is equal to 2. This equation is an example of the form f of r theta is equal to a number. If you're finding this video helpful, please give it a thumbs up and consider subscribing to my channel. Let's now learn how to convert a polar equation to a rectangular equation. This is harder than converting a rectangular equation to a polar equation. To help us, I've listed 4 techniques to convert our equation to one of these forms. The first technique that we can use is to simplify the equation using a trigonometric identity. The second technique is to substitute in r cosine theta is equal to x, r sine theta is equal to y, or tangent theta is equal to y over x. Another technique that we can use is to multiply both sides of the equation by r. And the last technique that we can use is to take the tangent of both sides of the equation. The 4 equations listed here in this red box will help us know where to start. When you work on problems like this, it's a really good idea to write down these equations before you begin. The first equation that we'll look at is theta is equal to pi over 4. The only equation in the red box that has just theta and not r in it is tangent theta is equal to y over x. So let's take the tangent of both sides of the equation. On the left, we have tangent theta, and on the right, we have tangent of pi over 4. Tangent theta is equal to y divided by x, and tangent of pi over 4 is equal to 1. We can then simplify this to the equation y is equal to x. This equation is a line through the origin at an angle of pi over 4. R can be any value along this line. Our second equation is r is equal to 5 secant theta. In our red box, we don't have an equation with secant in it, but we do have an equation with cosine in it. So we'll remind ourselves that secant theta is equal to 1 divided by cosine theta, and we can plug that in. This gives r is equal to 5 divided by cosine theta. Let's now multiply both sides by cosine, and we have r cosine theta is equal to 5. R cosine theta is equal to x, so our equation becomes x is equal to 5. This equation is a vertical line. Isn't it interesting that 5 secant theta is actually just a vertical line? Our last and hardest example is r is equal to 2 cosine theta. It looks simple, but it's actually the hardest one that we're going to do. In our red box, we have a cosine theta, but it's multiplied by r. So down in our equation, let's multiply both sides by r so that we can get r cosine theta. On the left-hand side, we have an r squared, and on the right, we have 2r cosine theta. We know that r squared is x squared plus y squared. And on the right, we have 2 times r cosine theta, which is equal to x. Now, unfortunately, we don't want to leave it like this. We're going to have to do some algebraic manipulation to make this an equation that we can actually recognize. Let's pull the 2x to the left and see what that looks like. We have x squared minus 2x plus y squared is equal to 0. If we put brackets around the x terms, we can see that this looks like a circle. To simplify this, we'll have to complete the square. So we're going to say x squared minus 2x is going to be equal to x squared minus 2x. What you do is you take the middle constant and you divide it by 2 and square it. Minus 2 divided by 2 is minus 1. So we'll add a minus 1 squared, and then so that we don't change the equation, we're going to subtract a minus 1 squared. This is going to give us x squared minus 2x plus 1 minus 1. Let's plug that in. This is x squared minus 2x plus 1 minus 1 plus y squared is equal to 0. The x's we can combine to be x minus 1 quantity squared, and then we have our y squared, and our 1 can go over to the right-hand side and be equal to 1. This equation is now in a form that we recognize. This is the equation for a circle of radius 1 centered at the point 1, 0. I hope that you're now a little more comfortable converting between polar and rectangular equations. In the next video, I'm going to go over all the different types of polar equations, such as ones like we just did, and I'll teach you how to recognize them and how to graph them.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.